think we're going to slowly get started. Thanks so much for attending. I counted like 70 people already, so it's pretty cool. Thanks to our sponsors as well, Telemetry, Eurotech, and Sierra Wireless for enabling us to do this, what I think will be a great day around IoT. We're going to be here all day in that room. And yeah, we figured it would be great to start the day with a kind of an introduction about the Eclipse IoT community. So I'm Benjamin Cabe. I'm with the Eclipse Foundation for about a month now. I used to be with Sierra Wireless, where about 2.5 years ago, we created a working group at the Eclipse Foundation to work on providing open source, what we call open source building blocks around machine to machine. At the time, the working group was called Machine to Machine. You might remember our website, our logo, and the first thing I wanted to highlight today, and just like also the theme for today is the IoT theme day. We actually figured it would be more relevant to call ourselves the IoT, the open IoT community at Eclipse, mostly because, well, when you think about and when you talk about Internet of Things, this is going to be familiar to most people. Pretty much everybody knows what the Internet is, so you can pretty much figure what that would mean to create an Internet of Things. Of course, some people will still do machine to machine. Probably when you talk about building gateways for bridging sensors to the internet, that might be called machine to machine for some people, but at least to me, M2M IoT, this is all the same, but the benefit of IoT is that maybe it talks to more people. So what is IoT at Eclipse? Well, it's just like Eclipse itself, it's an open source community, and it's also a set of open source projects around IoT. And in our case, that would be protocols, open protocols. If I mentioned that we are building blocks basically for the Internet of Things. So when you want to connect things, at some point you will need protocols, right? To build your network, and protocols that will allow you to have sensors that communicate using very bandwidth efficient protocols, battery efficient. So we try to have open source technology around the protocols that build the Internet of Things. Tools, as in development tools, basically. We are at Eclipse, so building on top of the Eclipse IDE, plugins for helping people develop their solutions, debug, simulate, whatever. So that would be part of our community as well. Frameworks, as in stuff that helps you build on top of hardware, wireless hardware, access the underlying system with nice APIs and a whole complete programming environment. So we have a couple of cool projects around the IoT frameworks, and of course later during the presentation you will learn more about them, and later today. And what we call services as well, like more verticals kind of things. If you want to build home automation solutions, SCADA kind of solutions, then we also have some interesting projects around that. So yeah, this morning, basically, it's going to be a pretty quick intro, nothing deep dive, nothing very technical, but the idea is to just make you more familiar with the projects we have, what's the roadmap, and what's in the future for us in the Eclipse IoT community. So, as I said, 2.5 years ago, we started that initiative, and basically from the very beginning, we already had the very 3 building blocks that you need when you need to build an Internet of Things solution. That is the protocol. At the protocol level, we started with IBM and Eurotech to have a nice open source project around the MQTT protocol. And of course, you will learn more about MQTT later today. But yeah, PAHO is basically the name of the open source project at Eclipse, where you have all the open source implementations for the MQTT protocol in C, Java. We'll see later what PAHO provides. So that would be the first project we had 2 years ago. Then we added what is called Mihini. So initially it was contributed by CR Wireless. Mihini is more an embedded framework kind of thing. So it's what helps you develop your embedded solution. And Koneki would be the tools. So yeah, we had these 3 projects. Paho, as I said, implementation of the MQTT protocol. Mihini is mostly based on the Lua programming language. So the idea is that you take Mihini, you install it on your embedded Linux platform, and you will have basically a scripting environment for your gateway, for your IoT device. And you will basically script your GPIOs and consolidate your data, push the data to the server in a very simple way, at least in a simpler way than if you were to use C, C++. It still provides the performances and the compactness of a C-like embedded framework, but without, basically even a non-programmer could manipulate Mihini. And Koneki is just the tooling counterpart of Mihini, providing all the Lua IDE for helping people write their scripts, their Mihini scripts. So that was 2 years ago. And in the last couple of months, and in the last year, actually, we had so many people, new projects, so many new projects coming. Now we have 13, as Mike Blinkovich mentioned yesterday, 13 projects around IoT at Eclipse. So yeah, in no specific order, let me try to just introduce you to these projects. And for some of them, you will actually have a more detailed presentation today. So one project we have is called Eclipse SCADA. So this would be more a vertical kind of environment for building SCADA solutions. So that is basically you have a plant where you want to monitor water tanks and all kind of industrial equipment. Then using Eclipse SCADA, you will be able to build not only the infrastructure for getting the data from all your sensors inside the factory, but also a nice set of tools as in an Eclipse-based tool for building your GUI and all your synaptics for monitoring the level of the water tank and stuff like that. So Eclipse SCADA is a project that's been available for a couple of months now. So basically, if you go to eclipse.org/SCADA, or maybe that is Eclipse SCADA actually, you will get all the information. You can access the source code, and this is going to be the same for all the projects. You check out eclipse.org/name of the project, and you will get more information. So what else? Cura. Cura is brought by Eurotech. And you might have seen the people counter in the hallways, which is, by the way, awesome. This is really a great demo of Eclipse IoT in action. So basically, Cura is what powers the actual people counter devices. You have this people counting device, and behind a Raspberry Pi running an embedded framework, and this embedded framework is Cura. Cura is basically similar to Mihini, except that it's using Java and OSGI instead of Lua, which means that you can build very modular applications, and you can basically have bundles for doing your data reporting, data consolidation, abstracting the cloud communication layer and stuff like that. Implementations of industrial protocols are built in Cura as well. So later today, you will have a presentation by Actuate and Eurotech about Cura and about basically behind the scenes explanation of what is the people counter demo we have this week. Mosquito. Mosquito is pretty much the server side for Paho. Mosquito is the open source implementation of brokers for the MQTT protocol. Supports MQTT as well as MQTT SN, which is MQTT for sensor networks, an even smaller, even more lightweight version of MQTT. So Mosquito is a broker that's very popular. It's been available in open source for several years now. And for your information as well, Since Eclipse IoT is not only a set of open source projects, but also an open source community, we provide on iot.eclipse.org's website an MQTT sandbox. So we run a Mosquito sandbox that everybody can use for building their solutions. You want to test your sensors and test your cool IoT application. Well, we are the broker for you already. You don't need to find to buy a server somewhere and then install Mosquito and stuff. It's already set up. It's completely open, which means that you need to share your topics and your what you do is going to be visible to everyone, obviously, but it's still very helpful for prototyping and stuff like that. So also on the server side, we have a project called Ponte. So Ponte is actually written in Node.js, and the idea is that when you build Internet of Things solutions, and later we will have a couple of drawings explaining some typical and exemplary architectures for IoT solutions, usually you will have sensor networks like an home automation solution where you have sensors reporting data like temperature data and stuff using, for example, MQTT. But you might have other solutions based on Modbus, on Co-op, whatever. How do you build an end-user solution? Well, Ponte, the idea behind Ponte is to bridge the world of the sensor networks to the HTTP world. So in Ponte, you can bridge MQTT networks to HTTP REST. You can bridge as well Co-op to REST and the other way around, which means that you can build nice UI using basically web APIs and JavaScript frameworks and things that are very, very, very popular among web developers. And Ponte will bridge the data from the sensor network to the HTTP world. Smart home. Smart home, we have a presentation later today. Smart home is a complete, ready-to-use, basically, solution for building home automation solutions. So you would install smart home on a gateway inside your home, and you will configure the way you want to choke with your alarm system, with your smart light bulbs, with your electric curtains and stuff like that. Smart home is based on OSGI. And it's, again, thanks to bundles, you can have a very modular approach for building your home automation solution. M2M, so recently, in the last couple of months, we had a couple of new projects at Eclipse that actually implement standards. Well, MQTT is also being standardized, by the way, at Oasis, and there are other standards around M2M and IoT. One being ETSI M2M. So ETSI is a European standards body working on the abstractions and service layers for machine-to-machine, both on the embedded side and on the server side. And basically, M2M is an implementation of that standard, so based on Java and OSGI as well. And during the lightning talks tonight, you will have a quick intro to what M2M is. So I said 13, so we have still a couple projects to talk about. Very quickly, Californium, you might know the Co-op protocol. Co-op is basically taking all the good stuff in the HTTP REST paradigm, as in being able to have resources that you can get. Basically, you want to get a temperature value out of a sensor. In the end, it's getting the value like HTTP GET, right? You want to update to close to open or close a switch. Well, you want to update. You want to put or post a command to a specific resource. That would be the switch. So with Co-op, basically you take all the HTTP model and you build that on top of UDP, which means that you will not have all the overhead coming from HTTP headers and stuff. It's very, very lightweight, and it's meant to allow building solutions where you have resources on your network and they can communicate with each other, observe each other. So Californium is an implementation of the Co-op protocol. Co-op is an IETF standard. And so Californium is written in Java. The cool thing is that it brings also the DTLS implementation, as in the lightweight SSL, basically for doing the security. So yep, Californium, the source code is already open source. Basically, it's already available on GitHub. But when I put here code pending is when the project is very new at Eclipse, so we still are waiting for having the code actually hosted at Eclipse. But in the case of Californium, it's already on GitHub, so you can already check it out. Wakahama, an implementation of another standard, this time coming from the Open Mobile Alliance, which is lightweight M2M. So I think right after the lunch break, we will have Julian from Sierra talking about protocols, and hopefully you will learn more about co-op and lightweight M2M. Lightweight M2M is on top of co-op, all the workflow that you need for doing device management, basically for the Internet of Things, firmware upgrade and monitoring the actual status of your M2M or IoT device. So lightweight M2M is brought by Intel to the initiative. Yeah, source code also available on GitHub and should be available pretty soon on eclipse.org. So it's written in C. It's very, very lightweight. I mean, it's really meant to enable device management on top of constrained devices, the very devices that build the Internet of Things. Cricket. Cricket is brought by Cisco, and it's actually pretty interesting. If you talk to guys like Cisco, people who actually build the network, the Internet of Things network, well, they start being worried, because if we are to have billions of sensors around us that report data every second, even every 10 seconds, then the network is not going to work, right? So with Cricket, the idea is to have a mechanism to filter and to configure the edge devices so as they have rules for reporting or not some values to the internet. So the idea with Cricket is that you have an API on your gateway, on your edge device, for basically routing some IoT packets, like MQTT packets. You would forward to a server the MQTT packet only if the payload is a temperature that is above 70 Fahrenheit, for example. So that's the idea beyond Cricket. So hopefully we will have the code available soon. But I think the idea beyond Cricket is very promising, and we're going to need technologies like this anyway. Yeah, last project that I wanted to mention, it's not a pure IoT kind of project, but it's still pretty interesting. It's called Concierge. It's a lightweight implementation of the OSGI standard. So for those of you who are not familiar with OSGI, it's basically a technology on top of Java, on top of the Java virtual machine for providing modularity and basically a component model. So it's pretty interesting when it comes to building IoT solution to be able to have modules for talking to the sensors, modules for implementing the drivers for such or such industrial protocols. And Concierge is basically a very lightweight implementation, just a few 100 Ks of jar file that you put inside your gateway, and you will enable OSGI solutions like Smart Home or like Cura. And yeah, it's pretty interesting. The code, actually I should have updated the slides. The code has been available for a week or so you can actually check out Concierge. Yesterday during the hackathon, I helped a couple people play with Concierge, and it was pretty fun. It's really super simple, but it provides all the OSGI goodness. And of course, we are an open source community. We are always looking for new cool projects. So if you happen to have anything that you might that's maybe open source already, or you have some cool ideas, we should definitely talk later today. So yeah, building blocks for IoT. We have all these projects. Where can you build using these projects? Well, I figured it would be a good idea to try to show a few typical solutions where you would use some of the technology that we provide at Eclipse IoT. Well, what if you want to build some kind of sensor network? You have devices and you want to be able to have all these devices to be able to talk with each other, like sensor, temperature sensors talk to other home automation related devices and stuff like that. So what can you do? Well, you can use Mosquito. You take mosquito source code or Mosquito already pre-built distro. You put that into a server. This server is going to act as what we call a broker. When you do MQTT kind of communications, you have a central broker that will dispatch data between data producers like sensors and data consumers like smartphones or web applications, big IT, big data, whatever applications. So your MQTT network, well, you will have your sensors or your Arduinos, your microcontrollers. They will run a PAHO client. So again, PAHO, these are the MQTT clients. You have clients in C, Java, JavaScript, C++, Objective-C, Lua, the Go language. And if you go to mqtt.org, you have even more languages. So basically, you can run an MQTT client on pretty much every device. And you will be able to have your MQTT network. Another option would be, as I mentioned earlier, you have something which is more heterogeneous, maybe. So you can use Ponte as the broker. So it's similar to Mosquito, but it's written in Node.js. And what it will provide is the same feature, the MQTT broker feature, but as well, you will be able to bridge your devices, your MQTT devices, to a co-op network if you want. That is, if you run Californium on your again, on your temperature sensor, Arduino, microcontroller, whatever, you will be able to use Ponte as a bridge between both networks. Ponte is a bridge in Italian, by the way. So you will be able to bridge the two networks. You can configure rules. What is the communication two ways? Is it only one way? Are there some conversions to perform and stuff like that? But that's the idea behind Ponte. So yeah, you take PAHO, Ponte, Mosquito, Californium, you can already build a sensor network, and this is actually what people do in the real life, right? If you talk to some of our sponsors today, or and I'm sure some of you in the room as well, these are actual technology that can go in production, right? It's not just for prototyping; it's also for it's production ready for most of these building blocks. Well, what about device management? Device management is when you want to have, well, the animation is kind of broken. You want you have devices on a co-op network, for example. You want to be able to monitor these devices, but you're, well, at some point you will be interested in the business data, temperature and weather, the humidity and stuff like that. But your devices on the field, you need to manage them as devices, right? If this is a wireless device, what's the signal strength? What's the battery level of my device? Something's wrong, I need to reboot the device over the air. So this is what is called device management, right? And so for this, if you want to build a device management solution, you can rely on the Wakahama, for example, which is the implementation of the lightweight M2M standard. So on the client side, you put the Wakahama client on top of your device. You provide, of course, we talk about device management, so Wakahama might know about some very generic features for doing device management, as in how to reboot a Linux device. But when it comes to being able to report the battery level of a device, you might have to implement your own porting layer, kind of. And so, yeah, you run Wakahama, and you will be able to talk to a lightweight M2M server, like the Lesson server, which is not yet part of Eclipse, but it's open source, and eventually, hopefully, it will join the Wakahama initiative. But yeah, you can already go check out on GitHub a lightweight M2M server that will be able to talk to the lightweight M2M ready devices on the field. And of course, yeah, device management, just like business data reporting, it's two ways. You will probably report some battery related yeah, what's the available memory kind of data that you will push to the server, and the other way around the server needs to be able to talk to you, to send commands, perform firmware upgrades, and stuff like that. So another kind of solution that you can build using our building blocks, that would be a home automation solution. So for this, we have a pretty cool technology. It's called Smart Home. Smart Home is the you run that in a gateway inside your home, and you will be able to bridge sensors with each other, configure rules. You know, when my temperature is above 70 Fahrenheit, I want to open the roof, I want to turn on the light and stuff like that. So Smart Home is able to understand lots of protocols, including MQTT. So you might have, as part of your solution somewhere, what we've seen earlier, an MQTT network, Mosquito acting as a broker between all your MQTT clients. But in that case, you would also have Smart Home being a client as well, being able to consume some of the data, being able to reach all the devices on the MQTT network. And yeah, as I said, you can provide, you install bundles in Smart Home for talking extend, serial, Bluetooth, Philips Smart Hue, whatever cool gadget you have in your house and you want to be able to control and make them talk to each other. So you do that, and what is cool also with Smart Home is that you have a pretty nice Android UI as well as a web UI, by the way. And so once you have configured how your home automation looks like, you will basically have a very cool UI where you will be able to toggle the light and control the temperature and stuff like that. And Kai in the afternoon will, I think, will have a very cool demo of Eclipse Smart Home. So that's, yeah, basically a few kind of solutions you can build with Eclipse IoT. Some people actually do build these solutions already, and as I said earlier, go into production with this technology. So you may wonder what's next. Well, this slide, actually, I didn't change it. It's like I've shown this slide a month ago at an Eclipse IoT event we had in France. And well, what I said and what I told the people last month is that we would really like to go more into the big data kind of thing with all this Eclipse IoT technology. Like we have all the enablers for all the protocols for being able to send the sensor data to the network, and what do you do with this data, right? Well, at the time I didn't know we would have the people counter demo here at EclipseCon, but I think that hopefully if you've checked out the demo already, or if you attend Marco's and Virgil talk later today, you will see that actually if you take technologies like Cura, MQTT, and combine them with a technology like Eclipse Birch, which is an open source technology for doing BI and data reporting, well, you can start being some sense out of the data that you get from the sensors, and being able to correlate the data, consolidate the data. So definitely it's going to be important to have open source technologies around the big data for the Internet of Things, and hopefully we already have some pretty cool stuff at Eclipse to do this. Security, well, security, this is a tricky part in that when you take MQTT or co-op with the TLS, well, you have security, right? In this, you can build security in your network, and your sensor network is going to be secure, but still, how do you come up with some kind of unique identity and identity federation across all your sensor networks? How do you manage authorization and identify what person has access to what sensor and stuff like that? Well, there's still a lot to do, but hopefully today Paul are going to give us some insight around security for IoT. And pretty much along the same line, everything around interoperability, well, we've mentioned Ponte. There's still a lot to do, I think, to be able to have kind of a real interoperability between all the sensor networks and being able to provide real data semantics on top of the protocols like MQTT and co-op. But yeah, we are slowly getting there. And actually on Monday, earlier during the conference, we had an MQTT interop testing day, which went really well. We had a dozen of MQTT implementations that tested against each other. And we already know that at the protocol level, we are in a pretty good shape. So now I think we need to go further up the stack in terms of, as I said, data semantics and stuff like that. So yeah, that's pretty much it for today. Just a few more things, a few upcoming events. Well, actually, Eclipse events where we're going to have a participation and we're going to be involved. On April 9, there will be an IoT day all around the world. And together with Postcapes, the Eclipse Foundation is organizing a virtual conference. So check out iotlive.org and basically, yeah, the whole day on April 9th, there will be a Google Hangout with lots of great speakers around open hardware, security, business models around IoT, big data. So it's going to be fun to have a virtual conference. Another Eclipse event, interesting event with great IoT content for the Europeans in the room in Florence, Italy. There will be an Eclipse Day with lots of great IoT content. And the last Eclipse-related event, but there are lots of others. Well, myself or Ian Scarrett from the foundation or other people from the Eclipse community are going to be present. But these are the Eclipse events. The other I wanted to mention is the EclipseCon France. It's going to be mid-June in Toulouse. The call for papers is open till mid next month. So please submit great M2M and IoT talks and or consider attending. Toulouse is a beautiful city, and yeah, we're going to have great M2M and IoT content. So that's it for today. If you need more information, of course, you talk to me later during the day. You make sure to check out iot.eclipse.org, where you will find all the links to the projects and more information about what we do. We have a live demo as well of the technology in action. And that's basically it. We have a couple minutes for questions, which I will be happy to answer. Yep, at the back of the room.
I was wondering what type of data protocols, data types, data packaging you're seeing. I'm hearing things like 70% of sensor data is JSON, XML is on the line, Allen RDF are hardly seen at all. Wall data with proprietary things. What types of things are you seeing?
Yeah, so question is, what kind of data-related protocols do we see, like for really modeling the sensor data and stuff? Well, it's true that JSON is very popular. We have people who also use, in co-op and lightweight M2M, they use TLV for storing the data because at some point you need a protocol buffer. It's also pretty popular. When it comes to sensor data, usually M2M and IoT related data is pretty easy to compress, and it's actually important to compress it because, as I said earlier, the network is maybe not ready for all this data, and also, of course, when you do cellular bandwidth costs money. So yeah, we have some people. I think Marco might touch base about that later today, but. Yeah, protocols like protocol buffers allow you to, if you are like reporting a temperature data acquiring a data every minute, and it's going to be always 20 degrees Celsius, right? And you want to send the data only once an hour, you should be able to craft a binary packet that pretty much says, okay, it's an integer, which means for the 20 Celsius, plus another integer to say I have 60 samples, and maybe another integer, which is the timestamp where you started the acquisition. But all in all, you should be able to really pack the data. When it comes to RDF kind of things, well, we haven't really started yet, at least at as part of our community, to build on top of that. But we've had several discussions around how MQTT topics can be used for modeling part of the semantics. And for the payload as well, there have been some discussions. So I think if you're interested, you can talk to Dave later, to some other folks in the room, and that would be great to try to brainstorm around data semantics. Yep.
So how about robotics? So I've been dabbling a little bit with our operating system, and there's definitely the architectural similarities here. Is there any integration or activity with those communities?
You said robotics, is that what you said? Yeah, well, what we see more and more, and actually I think when I will be back at home, I will have to check it out. There is a new kind of robot similar to the Now robot. I don't know if you've seen that one. Well, we see more and more robots that are actually open hardware, as we've seen earlier today. And most of them, they run Linux, right? So, and I think Andy Piper would have a great story about that as well. As soon as you have Linux, well, technologies like Mosquito, like Paho, they're pretty easy to install, right? If you have a Debian kind of installation, we provide already packages that you can install inside your device. So when it comes to providing like the MQTT integration and stuff, it's pretty much a regular Linux system you have, so it's pretty easy to install. And then if you need to talk, if you have some industrial protocols, robotics-related protocols, then yeah, maybe you have some other open source project that can help you, and you need to integrate that as part of the solution. But really for the infrastructure, I guess there wouldn't be too much of work for porting most of the technology to robotics platforms. One last question, maybe? Okay, thanks. So next speaker is going to be Dave from IBM.